Hello, comrades. So today we'll be looking at this problem 63 on LeetCode.com, unique paths 2. So it looks like a robot is located on the top left corner of an n by n grid. Um, the robot can only move either down or right. The robot is trying to reach the bottom right corner of the grid. If there is an obstacle, how many unique paths would there be? Okay. This is like, there's only one example, so you're given this grid, so you can see here that in order to, if you start at 0, 0 and end at 2, 2, the only way that you're gonna get there if there's an obstacle in the way is either this way and then down, or down, down, right, 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 because you can only move right or down at any point in time, and it looks like you can't go diagonal either. So this looks like a clear dynamic programming problem because what you can do is at every point or every index in the grid, you can determine how many paths lead to that specific space, right? So let's say if you're at over here at 0, 1, then you know that the only way that you can get here is through 0, 0, because you can only go, what is it, right or down, right? So all of the ones on the top row, you can only get there through one path, and then all of the ones on the leftmost column, you can also only get there through one path, because there's no way you can go left and there's no way you can go up, right? At least in the premise of this problem. So what we can do is we can draw a grid over here specifically for this problem, and you only go where the zeros are, right? So you can't go here. So you start up here, and so over here, you know that there's always one path that gets here, or there's one way you can get here, and that's through the start, right? Over here, the only way you can get to this square is from the first square. So you know there's also one path here, and the only way you can get to this square is through this square, right? So you're just still following this one path thing, right? Over here, the only way you can get here, because there's an obstacle blocking your path, is through the top one, so there's only one path here. And over here, well, you don't know yet, because you don't know how many paths are coming from this way, right? So let's go over to this square over here. The only way that you can get to this square is through through the starting square. So there's only one path here, and the only way you can get here is through the previous square. The only way you can get to this square over here is through this square. But now over here that you can see that there are two ways to get to this final square, and that's because you can either come in through here or you can come in through here. So it looks like for any square that isn't a top row or that isn't a leftmost row, you can get there by coming from above or from the left, right? But for the topmost row squares, the only way you can get there is from the left, and from these leftmost column squares, the only way you can get there is from above. So now that you know this, we have to build out some kind of 2D array that can hold the number of values in each square. And so we can look at the Python implementation for this. Basically, what you do is you first initialize this to 0, to all zeros, right? Because you haven't explored the number of paths that go through each index yet, right? So 0 times length of obstacle grid 0, That'll give you the rows. So you can see here in obstacle grid 0, there are is length 3. So this will give you 3 zeros. And then for the number of rows in obstacle grid, you can see this is a 3 by 3, so this one will give you 3 more. Or 2 more, I guess. And then this is your 2D array. So you have to start at index 0, 0, which is the start. So if the length of this obstacle grid is 0 or it's 1 and there is an obstruction in it, so that's like the case that if it was if it was just this that you were given and there's a 1 in here, then you know that you cannot get to the final index. So that way you have to return 0. If this isn't the case and the length is 1, meaning just this one array, and there are no ones, then it's a clear path, so there will be always one unique path, right? And if this starting index isn't blocked by a 1, then you set the memo table equal to 1. Otherwise you have to return 0. So while I is less than the length of this obstacle grid, and while j is less than the length of each row in the obstacle grid, then you keep going. If there is an obstacle or there is something already in its place, then you continue on to the next then you just ignore it basically, right? Because if there's an obstacle, then you don't want to change anything in the memo table. You want to keep it as there are 0 unique paths to get to that index. So if I equals 0, then that means it's in the first row. Or if j equals 0, that means it's in the first column, right? So I equals 0 is here, and j equals 0 is here. So if I equals 0, the only way that you can get there is from the previous j in the same row, right? So if I j equals, if you're looking at this one over here, if ij equals, 0, 2, the only way that you can get this, the number of unique paths that come to this index are from the previous one, which is over here, right? So you have to look at j minus 1, which would be 0, 1. Likewise, if you're in the first column, then you have to look at the index from above. So this is memo I minus 1j. So if you're trying to figure out I of j of this one over here, this would be I of 2, j of 0. The only way you can get it is from the one above it. So you have to do I minus 1, which would be 1, and then the same j. Otherwise, if you're looking for the number of unique paths in one that isn't hindered by an obstacle, but also isn't on this top row or the leftmost column, then you have to look at the ones from above it and right of it to determine, right? So this one is I minus 1j plus ij minus 1. And then basically you just iterate through every one of these to determine. So for me, I did j. So what this does is it looks through each row before before moving on, right? And then if you're at the very end of your row, then you need to move on to the next one. So that's why, like if you're here and I of j equals 0, 2, then you have to go to I equals 1 and then j equals 0, because otherwise you're just going to go off the grid. So once you finish that, you can determine what is it, the very last index in your 2D array to determine how many unique paths there are to get there. And so, for instance, if we're given this obstacle course of 0, 0, 0, 0, 0, 0, 0, 0, 0, then we would generate our memo 2D array something like, you start here, so there's one path to get here. You need to look to the left, so there's one here, and there's also one here, right? Because there's nowhere else, no way else you can get there. From here, you have to go down, so this one is also one path to get here. And now over here, this isn't the topmost or the leftmost column, so you have to look at above and below. So 1 and 1, you add these together, and you can get, there are two ways to get here, right? Over here, there would be 3 ways to get to this square. This one's 1. This one you have to look at the 2 and 1, so there's 3. And then over here, you have to look at 3 plus 3 is 6. And just for a sanity check, you can count all the possible ways. So there's 1, there's 2, there's 3, there's 4, there's 5, and I might have missed one, but there should be 6. Yep. All right. Thanks.